puppies are coming for you.
Make some noise for the seeing eye.
Sporting the purple bandanas are our barking biologists, and the blue bandanas are our canine chemists. Hearing a lot of noise for the canine chemists.
The canine chemist almost scored a touchdown there, but they fumbled the ball right before the end zone.
We've seen quite a few exciting scores. We have seen some very thirsty pumps, as you can see. We have a nice close-up camera. And we're starting off strong. We've already got one down with the ball. Oh, we dropped it. That was really fast. Football somewhere.
I see two different players with a football. I can't tell if they're getting into the end zone over there.
Now, one of our friends out on the field who is currently going for the ball is Forrest. Forrest is going for Newt, who has a ball. Newt is carrying the ball. It was stolen away by Forrest. Run, Forrest,
What
run.
a great tackle there.
He dropped the ball. I told him to run, Forrest, run, and he dropped it. Now someone's got another ball. And she dropped it, and she picked up a different ball because she didn't like the original one.
Got two players on the same team fighting for the ball.
That is Forrest, who is trying to get the other ball.
That's so funny.
We're getting very excited over here. Refs, do something.
I think we need some interference here from the referees.
They lay down, closed their eyes, and they didn't move for about 20 minutes. They were all sleeping.
They were very tuckered up on that last game.
They were so tuckered out.
I will just let everyone know that we have got 10 seconds left in this game. Can the chemists come back?
That's a tennis ball.
That's a tennis ball. That's not going to count. 5, 4, 3, 2, 1, and the biologist wins!
And the crowd went barking back.
Male. You click something. You broke it, Marcus. Get out of here. It's gonna be funny. What
Now don't even correct it.
Physical to us, but it's all around us, and that's because gas is very exciting and it spreads out all over the place. Now, I've been talking about something that is solid first, and this piece of solid is negative 104 degrees Fahrenheit. So I'm going to get myself a good chunk of it right here, if I can find one. Oh my goodness. Okay, there we go. Now, it's a little small, but you can see some of this coming off of it just a little bit as I'm walking around. So this here is pouring a little water inside. Now what I've done is I've actually made a little bit of cloud here. Now that's cool itself, fun intended, but we can actually do something really fun with it. See, that soapy water is very helpful for making bubbles. One more try. There we go. There we go. And then a thought from me anyways. So what these little bubbles are actually filling up with is a gas that we're very familiar with. In fact, you're breathing it out as I talk. Carbon dioxide. Yes, indeed. It does sound like whatever inside of here is boiling, because that's how that sound's being made. But we just talked a little bit about how boiling is hot. Because out of curiosity, by raising hands, who here's boiled water for pasta? Or maybe even cocoa? Yeah, but that's really hot. But this is not quite that. In fact, hello there, my friend. Can you stick up 2 fingers for me? Hey, can you touch that real quick? A little bit. What's that? Hot or cold? Ooh, okay, let's double check. Can you touch that for me? Was that hot or cold, my friend? It's chilly. Now, if I just carefully get a good little bit inside. There we go. I'm going to pour the rest in there. And I am going to use a very fancy device called a balloon here. And what we're going to do is we're going to put that right on top. And it's actually pretty quickly inflating there. That's because as I stand here, the liquid nitrogen is boiling at room temperature. It actually
The scientific idea of black holes first showed up in this scientific paper by this guy named Einstein back in 1939. In this paper, he was using his new theory of relativity, and he had ideas like what would happen using his theory of relativity. But if it's really, really far away in the nighttime sky, it's not so easy to see, right? It's very tiny and very dark, and our eyes only see things when light goes into them. So how can we find black holes that actually exist in the nighttime? So a black hole. And because it's so close, and the black hole's gravity is strong, it's just sucking material right off of the star and eating it. And this stuff from the star doesn't go straight inside the black hole. It kind of swirls around first, so that's what makes this disk going around the star. This disk is called an accretion disk. Faster, yeah, they speed up when they get close to this thing at the center, because this thing at the center has strong gravity. So when they get close, it pulls on them really hard, and that's what speeds them up. So this thing at the center, we do think it's a black hole. And based on how much it speeds them up, we can figure out how much gravity it has. It turns out that this black hole has about 4... This picture of a black hole that was taken before that other one, it does look very, very similar. This is a picture of a galaxy, of a black hole in a distant galaxy, M87. Now, we do think that it's not just our Milky Way galaxy. We think that every single galaxy out there in the universe, so here's our Milky Way galaxy that we're inside of, and here's all the other galaxies, and we think that every single one of these has a supermassive black hole in its center.
It grows so heavy, it buckles in on itself. Then, the collapse sends a shockwave roaring out. The star digs itself deeper into space-time as a black hole forms at its center, and the giant goes supernova. When the dust settles, what's left is a black hole, an object 1,000,000 times the mass of Earth, but 1,000,000 times smaller. We estimate there are tens of millions more. But then gravity doesn't stop there. It turns out there's a whole other breed of black hole out there. Peering into galaxies beyond our Milky Way, astronomers have found that nearly every one harbors an immense black hole at its center. To learn where supermassive black holes came from, scientists have recreated these early times with supercomputer simulations. They can trace the long, steady process that formed galaxies. From the start, gravity reigns in the cosmos. Billions of years later, and across billions of light years, Swift is today scanning the heavens for these same early supernovae, the stuff of solar systems and us. So how did our galaxy make out of all this? Astronomer Andrea Ghez wants to know, have dust, stars and hot gas, and it's always rush hour. Approaching dead center. The way is already strewn with signs of havoc. Supernova remnants and swirling clouds. Their guide is Einstein and what his equations tell them. Space here is so warped, the black hole acts like a giant lens, twisting the light that scatters across it. At last we cross the event horizon, the point of no return. But don't expect the inside of the